Welcome back, everybody. I hope you had a good break, whether you're at home or in the session here. A couple of just quick housekeeping messages before we get started for the second session. Just to confirm, everyone that has registered for this event, whether you're face-to-face, online, or post-seminar, will have access to the recordings for 6 months. So we are not putting together individual PDF files of the presentations. They will be 4 recordings: session 1, session 2, session 3, session 4, and everyone gets access to those for 6 months as part of their registration. Second note is that, again, thank you to our sponsors. We have lovely lady Lara sitting at the back who's representing Aureus, and she has some products from Aureus. So if you do get the chance during lunchtime or the break, feel free to have a chat with Lara. And during the lunch break, where one of our other sponsors is the Plexa software, we're going to get Craig to do a demo if you are interested. No compunctions. That's going to start at 1:05. So that gives you 20 minutes to have some lunch. If you want to come back here and just listen to Craig run through a bit of a demo of the Plexa software, you're most welcome. That will also be live streamed to those people at home if they want to see a demonstration of the Plexa product. So without further ado, I'd like to introduce the first speaker for this session. As we talked earlier today, QA/QC is not just about sampling and analysis. However, this session is all about sampling and analysis. So the first speaker is John Horton. John is a geologist with 38 years experience in exploration, mining, and mostly resource estimation. He's currently an independent consultant and works for Resival. He's going to present a talk on the importance of assay method and the role of CRMs and check assaying. Thank you, John.
Thanks, Mark. So it is on. Yep. Yeah, this presentation I made 4 years ago in preparation for this conference that got delayed, but nothing's changed, has it? So I'm sure some people are going to be talking about all these different types of QC samples that we take for assay control, and they all revolve around understanding precision and accuracy for things. And they'll get reviewed at different stages of the exploration cycle. So there's going to be the original batch acceptance, and on a mine site that's usually formalised. And then there's probably a periodic review by the same team, exploration geologist or someone who then looks at time variance and maybe hopefully looks at his duplicates and sees how the spread of the data is, etc. And they're all looking at current data, recent data. But when you come to the resource work, it's usually a toll gate for the entire project. So you're looking at everything going backwards. And from a point of view of a resource estimate, maybe precision isn't such a big issue because it is what it is by the time it gets there. And it only adds to variance, which just gives you uncertainty, and uncertainty we can accommodate with classification, yeah? So it's part of our consideration, but it's not a red flag. The red flags are accuracy. So when I review QA/QC, it's usually with respect to particularly red flags that are going to stop you from being able to use the data for some reason. So CRM, and probably everyone here knows what it is, but just remember it's actually a real sample from a real project that's a mineral sample that's been pulverized as normal and then mixed in a special bit of kit by a specialist group usually, or a lab. And then they send it off a round robin analysis to a bunch of labs to get an expected value. And that's usually based on a particular assay method. And most CRMs only have one assay certificate, therefore for a particular assay method, like a fire assay. And that's what it's good for, and that's what you use it for as a rule. Now that varies to what we call standards, and we tend not to use the term standard for CRMs, mainly because standards imply a known grade, not an implied grade. And so the labs use real standards in the lab to calibrate their equipment, and they're made up from chemical compounds that are actually known as absolutely correct. And if I get nothing over to you today, you've got to remember that CRMs are only a measure of relative accuracy, relative to your mineral matrix relative to your assay method that you're using. And sometimes that assay method isn't the right one. So basics, we insert the CRMs into every batch for monitoring the batches to some degree. And hopefully over a regular basis, it gives us some independent validation of the whole process. But we need to do more than that as geologists. We need to look beyond what the chemists do, because that's all they do, is to look at everything relative to that assay technique. So I actually have an ORAS CRM here, and she's putting a thumbs up at the back. I didn't realize you were sponsored. But this is actually an old certificate from an old nickel laterite CRM. I just brought it in because it was one of the first ones I saw that had such a really nice data pack sitting behind it. And there's lots of pages. There's about 20 pages in this certificate, and there's lots of information in it. The main ones you're going to use to select a CRM is obviously the elements that are covered, that they cover all your economic and your deleterious elements. And if not, then maybe you need a couple of different CRMs. There's also the grades, expected grade. You really want your expected grades to be in something that's useful from a resource and economic point of view. So you want something that's probably marginal cutoff grade to medium grade to high grade. And I know some people run low grade CRMs. They're probably useful for detecting contamination issues, but from an accuracy point of view, you need something that's away from the detection limit to be useful. And what else was I going to say? There's also the assay method, of course. And in this case, this CRM has actually got two assay methods. It's XRF and it's ICP. And the fourth thing that's really useful is the source material, which gives you as the geologist an idea as to what the actual mineral matrix might be in this sample. Unfortunately, they don't provide a lot more detail, but it tells us where the nickel laterite came from, the type of style it is, and the facies from which it came from, which then gives you an idea of the mineralogy. I'm going to digress from progressing on because there's so much information you can get from just an assay certificate like this, because they've done so much assaying. We can actually look at we can actually learn a few things. So when this one came out in 2011, it was actually a little bit of a revolution because a lot of the labs were still selling ICP 4-acid digest, which doesn't give you silica. For nickel laterite, that's not what you want. But a lot of people, exploration geologists, don't realize what they need to do down at the back end of the metallurgical process. So when this came off, it was actually different to what most of the labs were actually assaying, because they used fusion ICP on this CRM. So for me, when I saw this CRM particularly, it was a bit of a revolution in someone's actually starting to think ahead, because I'd spent 10 years trying to figure out what was going on with assaying between ICP and XRF. And it took me 10 years of experience on feasibility studies to figure out that there's actually a fundamental difference between the two assays. It's only slight, but it shows. And it shows on this CRM as well as all the CRMs in the series of this date, where you might not be able to read it, but the nickel and cobalt, they're just a tad higher in the XRF. And actually every other element's a tad higher as well. And it happens on every assay. So there's a fundamental difference between these two assaying methods. It's not just a bit of variance. I've subsequently learned that it's moisture. And these samples are hygroscopic, so they suck up moisture. So it's basically the ICP samples are assayed wet. They're not assayed dry. And that's why there's a systematic difference. And it's probably endemic in every ICP assay ever done, but you just don't notice it because you don't deal with samples like this material that is particularly hygroscopic, which can suck up to 5% of its mass in water through a paper bag overnight in the lab. And one of the lab managers has actually admitted to me they never do the ICP on a raw sample out of the oven, because they can't measure the 2 grams off because it keeps on going up in weight while it's sitting on the scales. So they leave it out in the lab overnight to suck up moisture and stabilize. So he admitted the fact that he knew he was biasing the assay by not managing humidity in the lab. But you can gain that from just looking at something like the massive information that's in here. Another really interesting one is the data pack that goes behind it. You probably can't see it, but this CRM went actually out to 17 labs. It must have been every XRF lab that did nickel laterites in the entire world. And the assay results for nickel here, they're all really consistent. They picked out 4 or 5 outliers, but they're actually almost consistent with the rest of the data. The XRF data is all done the same way, the same flux, same machines. They're probably all pan-analytical XRF machines. The data is ridiculously consistent. And when we look at the fusion ICP results, we start to see the complications we have with the assay method. There's different labs who use different fluxes. It's generally consistent, but we got one lab with a couple of outliers, the individual outliers, and then we got one lab that got struck off totally. So this one in column J is all bold because its numbers are totally different from the rest. And whenever I drill down on an ICP packet, I normally find this is often the case. An entire lab gets taken out. So it's starting to tell me something about the assaying technique, even though they take out the data that's way out, and they give you a standard deviation for that CRM that's based on the data that they think is reliable. But there's actually a whole bunch of data that's regularly wrong. So we know when you just looking at this data, we probably need to design a totally different CRM insertion rate for ICP work than we do for XRF. Mainly because the labs are more likely to get it wrong, because this data tells you that it's not that Lab J actually got the wrong result. They probably just got it on a bad day. And labs can have bad days with an ICP because it's a fairly complicated process, yeah? But I just thought it's a nice digression to actually see that you can actually draw a lot from a CRM package if you don't know a lot about assaying for the minerals that you're looking at. So I've talked about the fact that the stats on a CRM are interpretive. You should drill down and have a good look at it if you're starting to get issues. You might need lots of CRMs to cover all the elements you need. You might need to cover CRMs to cover the grade range and the different mineral matrices that you might have within a deposit. So you can start to see that on a nickel laterite, you might need 6 to 9 to really cover the range of complications that may come with some minerals with an assay technique. The key thing for a CRM is it's only relative to the assay method. So it's only a relative measure of accuracy, okay? And that's all it's going to give you. The CRMs, they're never blind. The lab manager always knows the CRM, the weight's different, so he can pick it just by sitting in his little office at the end. And if he's a good lab manager, he's using your CRMs to monitor the data as well. Okay, and it's nice to see when you hear the lab manager actually recognise your CRMs, because there's only so many on the market. They know the grades, they know what you're running, they know you've only got 5 or 6 probably in your kitty, and they will use them. Of course, CRMs, we're doubling up. The lab does a bucket load of CRMs already. They use CRMs, to save a bit of cost, sometimes they use internal standards, which are like CRMs, and then they use standard reference materials as well to calibrate their equipment. We don't see the number of times that they repeat the assays, and they commonly are repeating behind the scenes whole batches of data based on those CRMs already. So the amount of CRMs we put in really should be just to catch the fatal flaws, not to probably pick up the stuff the lab should be doing anyway. What you should be doing is making sure the lab's doing their job right, and making sure they target their CRMs right. I'm just working on a project this week. It's a gold project. Antimony is of interest, but the only CRMs the lab was running for antimony that had antimony certification was only done for fire assay, probably because the client never told them that they needed to that they're interested in these other 4 elements because they're key to the project as well. So all these limitations, that's why you do check samples, because check samples overcome some of these limitations. They have a grade range that's more suitable to your project because they are your samples, particularly when you picked out the grade ones. They have a mineralogy and the mineralogy mix that's exactly the same as your project, and they are done blind. And the 4th point is you can run them for different assay technique. You don't need to run the same assay technique. I don't think I've ever seen a project where the regular QA/QC data sampling, they actually ran with a different technique. I've only seen it when they've accidentally run it because they were looking for some other elements, or they were chasing up QA/QC issues and they had to go to a different element assay technique to figure out what the problem is. But like I said, think about looking outside the box, not being the chemist and saying, I'm only interested in this technique, actually look further afield. So I've got a project example. This one isn't mine, but I got asked about it. It's actually a tantalum standard. It had a second round of assaying to become to get lithium values as well. But both the lithium and tantalum have two different assay techniques there and fundamentally different assays. 10% difference, 11% difference in tantalum grade, it to me is a big issue. Okay, for chemists, sometimes they're comfortable with that because they know the techniques are different. But for me, it's a red flag that this method, maybe one of these assays is wrong. When we actually drilled down into the data pack in here, it supposedly went to 10 samples at 5 labs. Only 3 of them actually did XRF, so they only end up with 30 samples of XRF. And in this data pack again, one lab on ICP was so badly wrong that it got thrown out, like it was way higher than everything else. And another lab gave them XRF results, its ICP results that were only reported to 100 ppm accuracy rather than 1 ppm like all the other labs. So the data was basically not fit for purpose for the CRM. So when we drilled down on it, both the ICP and the XRF had the same number of samples behind the scenes. The ICP just had a lot more variation, a lot more problems coming through with the lab. So they didn't actually certify the tantalum. They just said for XRF, they said it was indicative. But being a geologist, I know I've gone phosic for tantalum. It's a resistive mineral. It's really hard to get into solution. Yeah, it's a tough mineral. It sticks around. It's used in heat shields of spacecraft. That's one of its uses. It doesn't melt very easily. And I doubt whether I'm not even sure it would melt in the temperatures they use for fusion analysis. So it may not get distributed. It may not actually get changed in a fusion analysis. So I have some serious misgivings about the methodology for that type of mineral. Things like tungsten and tantalum are really tough minerals, and maybe rutile and things as well, chromite as well. So it's an interesting example. The client had the problem because the assays all came back at the same grade as the XRF. So what's the bet? The XRF was probably the right assay, and the certification for this standard is actually completely misleading because it's not right. It's not the right grade for the mineral, for the CRM. So feel free to question these sorts of things. So I've got a case example I presented a few years ago in the Mining Geology Conference. It's a client that came in and re-drilled the laterite deposit. They got misled into using ICP4 to digest, which they shouldn't have, but anyway. But they did everything else right. They did their duplicates, their blanks, they did commercial CRMs, they did check samples. There wasn't a scandium standard CRM around. So they actually went and drilled holes to get enough material to make a standard and get it certified by a professional. They had a professional QA/QC reviewer, and they had a major consultant report doing an NI 43-101 report. Few little questions on the QA/QC, a little bit under in a few places, but otherwise everything got green lit. We came back and we wanted to use XRF for the future work in the second round of drilling. And we found really superior assay quality that then threw in problems with all the old data. So just a sample of the old data, the original program. These are just the check samples. They had 2 primary labs. They changed labs at the later half of the program. Pretty good, bit of scatter. Check lab checks out okay. When we drilled in the database to try and find out where the silicas actually came from, we actually found out that somewhere in the program, they started doing XRF results to get silica, probably. There was only 10,000 of them just sitting there that no one had ever looked at ever before. When you plot it up, we find our normal little bias. That line almost looks straight, but when 10,000 data points, we're pretty sure that's a 6% bias for nickel and cobalt on that. That's our moisture issue, which is our standard assay bias with ICP. Yeah. So that made a material impact to the resource because we changed our primary assaying technique for nickel and cobalt. When we then started reassaying for the new program and reassaying some of the old holes, we got similar issues, similar, very, very small, but the detectable biases on nickel and cobalt for our new XRF. But when we did scandium, we started to see really big changes. Okay, for the primary lab, First primary lab, it's 10% bias, and the second primary lab, it's a 20% bias. Some of the samples were coming back from waste to high grade on reassay by XRF, really significant, because the grade profiling on scandium is so, it's pretty shallow. It's not easily upgraded. So we've got XRF there and to comparison. So we had to question what was the right assay, because I'm no longer interested in the CRM because it's rubbish, because it looks like it's out. We've got to figure out what the real assay of the grade material is. So we ran more XRF and got perfect alignment. We then went to neutron activation, which is the gold standard quantitative type method for resolving these types of things. And we got perfect alignment with scandium cobalt. They just wouldn't give me nickel because he wasn't comfortable with it. We then went back and did ICP again and did fusion, but we went and found a method and lab had set up for specifically for scandium, and we got a small bias again, but again, that's our 6% bias that we see in nickel and cobalt. So we're starting to see confirmation even by ICP when they do a better technique within the ICP methodology of our new grade of what we thought we were actually getting. So this is the actual accumulation of all the scandium assays. So the first bottom 5 graphs down the bottom are actually the original certification of the internal standard that they drew up. There's a bit of variation. There was a lot of data thrown out, like we often see with ICP when we drill down. The next 3 bars are the exploration program initially. There's 2 primary labs there. Bit of spread, a little bit under, didn't raise any red flags when we started reassaying. And that top one up here, that's an entire exploration program, and that's how tight the data is, really precise, much higher grade, and a totally different assay. And when we compare it to the neutron activation and the other XRF lab, which was the only other XRF lab that I could find that would actually report scandium at the time, I got the same result. So I'm happy that I have to recertify this number. It brings up the problem that even when you have two assay techniques, which one's the right one? And is one of them fit for purpose? Okay, if it's not, yeah, if there's a difference, one's got to be wrong. It's not the chemist's view. The chemist will say they're both right, but as a geologist, you know one of them has to be wrong and to move forward from that. Am I going? If I get nothing over to you, John. Sorry, if I get nothing across to you, then question the assay technique. Make sure you do your check samples, because most projects, they don't get done. They do tell you some interesting information. Think about running your check samples for a different lab, a different assay technique, to really question the whole complexity of everything that we're trying to do. I think I'll leave it at that.
Thank you. I didn't actually count the number of times that John used the word lab, but it's perfect to segue into the next 2 talks, because they're both focused about your relationships with your laboratories in terms of Anita's presentation. And then we're going to be really interested to see and listen to Mark talk about the QA/QC issues with respect to how a lab treats them. So I'd like to introduce Anita now. Anita is a consultant geologist whose experience is defining large ore bodies and developing procedures and systems led to a career in database management and QA/QC. You need to get a life.
And this is my hobby horse.
Her talk today is on maximising your lab relationship. Thank you, Anita.
Maximising your lab relationship. Some practical pointers to assist your quest for QA/QC excellence. My interest began in earnest post-BRIEX, which to some of you might seem as long ago as this lab. I vividly remember being at an AIG seminar in Perth in '98 and listening to how Freeport uncovered fraud at Busang during their due diligence. You could have heard a pin drop. Post-BRIEX discussion about best practices resulted in technical reporting guidelines worldwide. The allied quest for QA/QC excellence is ongoing, hence this seminar today. Later in my career, I was tasked in Kalgoorlie to organise lab tours for every geologist for a large multinational. Some labs I visited up to 6 times, and every time I learnt something new. A very good relationship I had in Kalgoorlie started when I was a graduate, with my bosses placing great importance on lab visits during a resource drill out, and that was reciprocated by that lab manager. Conversely, an ex-colleague who had no lab relationship and no knowledge learnt the hard way when his carefully collected soil samples were submitted for the wrong method, and they all came back below the too high lower detection limits. Why should you have a lab relationship? Using a lab's not just throwing a few QC samples in, filling out a dispatch sheet, and it's sorted. It requires planning, gaining knowledge and communication. Do you understand how your carefully collected and representative samples are prepped? Are you using the best assay methods? Thanks, John. What's your plan when your continuously monitored QC samples appear awry? When's the last time you visited a lab? If you can answer these questions, you're on the way to maximising your lab relationship. Additionally, you'll be reporting your assays. JORC reporting criteria includes supplying commentary on the nature, quality and appropriateness of sample preparation, assaying and laboratory procedures. QC measures to maximise subsampling representativity, the nature of QC procedures adopted, and if acceptable levels of accuracy and precision have been established. With a good relationship, you'll be working towards addressing this criteria. To build a relationship, it helps to fully understand your program needs, be willing to increase your knowledge, and engage in ongoing and continuous communication. Today, I'm going to outline my hobby horse, which is 4 non-linear practical pointers to assist. And these are communication, planning, lab flow charts, and lab visits. Alone, we can do so little. Together, we can do so much. Helen Keller nails the importance of communication and collaboration to achieve successful outcomes. Firstly, let's recognise individual and mutual needs so we can create effective communication. What does a client need? A client needs appropriate and quality prep methods, assays and lab procedures, acceptable levels of accuracy and precision, cost-effective assaying, transparent and timely turnaround, and delivery of lab QC for review. A lab juggles multiple clients. You're not the only one. A lab wants details of client's program, including physical and mineralogical characteristics. A lab would like clients to understand the nature of the sample prep and assaying. A lab prefers consistent delivery of samples in acceptable numbers with transparent scheduling, and of course, timely payment. Meeting mutual needs promotes a successful program, and these mutual needs include assays meeting performance indicators, such as prep sizings and sample QC results, a clear understanding of prep methods, assays and lab procedures. This can be assisted by a flowchart. An ongoing relationship and knowledge building. This can be promoted by lab visits. Clear communication channels. Timely and ongoing QC analysis of both client and lab samples. A willingness to address, solve and document QC issues as they arise, and they will. And lastly, check-ins proportional to the size of the project and stage of exploration. Now we've identified individual mutual needs, let's outline some actions by the client for successful communication. Convey your program's plans to the lab. Employ the lab's technical expertise for input for your sample prep and assay. Collaborate with the lab on your flowchart. Use visits to build relationships and increase knowledge, and commit to timely and respectful QC issue resolution. A variety of communication channels can be used depending on needs, logistics and issues. It takes as much energy to wish as it does to plan. And we've already heard a lot about the importance of planning earlier today. Planning can be divided into 3 stages. The first stage is defining your program parameters. This includes stage of exploration. Is it early, initial drilling, resource, grade control? Your target or anomaly definition and assessment needs, mineralisation style, type of sample and sample size, mineralogy, grain size. Are there any hazardous materials? What assay elements do you want and how will you use them? Number of samples, size of program, frequency of submission. These all obviously impact on sample prep, assaying and QC planning. What is your data quality objective? The second stage is gathering information to choose a lab. ISO and NATO accreditation is a good starting point. Then lab schedules, meeting and visiting the lab, and possibly industry references can be used to assist your decision making. Outlining your program to the lab can assist appropriate methodology selection. Other potential queries to assist your decision making may include the logistics of getting samples to the lab, the turnaround. Prep queries may include, are your early exploration samples separated from grade control? What's the chain of custody and reconciliation procedures, subsampling procedures, prep sizing specs, oversize, undersize, and wet sample protocols? What's the prep cost per sample? Most importantly, what are the appropriate lab methods for your stage of exploration, sample type, etc., to achieve your required accuracy and precision? What's the batch size for each method? This will feed into your QC protocol decisions. And what are your significant elements up a detection limit and consequent higher detection limit methods? And of course, what's the assay cost per sample? What's the best way to get additional elements not routinely supplied? What's the ideal dispatch size? What lab QC is undertaken? Its insertion rates? And is it all reported to the client? Is there any online delivery portals and tracking of sample progress? And what's the storage and return of samples protocol? Once you have all this, it's time to choose a lab. It's good to document lab and assay method selection, including pros, cons, costs, and final decision in context of appropriateness for your program. For costs, are you using a lab schedule, a personalised quote, or a contract? This will often be company and/or project dependent. This is where I advocate for a lab flow chart and a lab visit to increase your knowledge and improve communication. It's also important to discuss preferred communication channels and note client and lab contacts. A good idea is also to outline sample submission expectations and let them know if it changes. A lab flowchart outlines your sample progress throughout the lab. By clearly defining processes and signing off by both the client and the lab, you're minimising any potential misunderstandings. This is a due diligence chart that I thought you'd find interesting. I've circled the 3 different sampling processes as it's a bit complex. The yellow on the left shows the original BRIEX sample flow. The orange shows the first pass Freeport due diligence, which included drilling and reassaying 500 coarse rejects. And the pink outlines the more detailed due diligence as Freeport's program progressed. That included flying 2 holes to New Orleans and 1 hole to Irian before submitting to the usual labs. You can see the multiple sampling and assaying media, locations and methods used to cross-check the process. The lab flowchart combines lab codes with extra detail from your information gathering. The detail ideally includes your project and client-specific requests such as QC and sample return, and additional information such as drying temperature and time, prep equipment name and specs, subsample product names and storage, and lab QC names and insertion rates, and their position in the process. The assay decomposition subsample weights and batch sizes are good too. Note the client contact for reporting and report style and delivery. You do want a non-editable certificate as well as digital results. An extra internal client flowchart can also include details of client QC and umpire assays. Here's two Australian examples from recent NI 43101 reports. On the left, Karora Resources clearly shows sample receipt and reconciliation, the different subsample stages and products and lab QC. And on the right, Newmont Tanami additionally notes reporting dump data and umpire checks. At the very least, the project manager and QC or database manager should visit the lead laboratory to become familiar with lab personnel responsible for handling the client's samples, as well as the process used on those samples. This quote, which I paraphrased here on screen, is from a very recent paper by Barry Smee, Linda Blue, Dennis Arney, and David Herbeline. Do yourself a favour and read this practical and detailed QA/QC paper today. It's available as open access on the web. Out of curiosity, hands up, who's visited a lab in the last 5 years? That's pretty good. The last 10 years? I'm not going to ask any more than that. I see Mark's hosting an ALS lab tour in Perth for Gold 24 in October. It's a great opportunity to look at the latest lab practices. Visits are especially important when your project has a new phase of drilling, a new lab, or new QC protocols. A more formal or detailed audit can be conducted by a geochemist for later exploration stages or to address specific QC issues. Your lab visit aims ought to include familiarising yourself with lab processes for receipt, prep, assays and reporting, reviewing QA protocols, machine and instrument use and calibration, how contamination is minimised, how sample mix-ups are reduced, how and where lab QC is used and assessment procedures, and obtaining overall impressions about cleanliness, work health and safety, and professionalism. Most of those are part of ISO and NATA accreditation, but it's your samples and you need to be informed. Many moons ago, I did see some shoddy lab sample splitting for another client, and I often wondered if they'd ever done a lab tour. They're also a great opportunity for younger geos and senior fieldies to increase their knowledge. So during lab visits, it's useful to have a standardised table to prompt questions and record visits. A lot of these queries I've already talked about, and you can see them here. You could also ask a few other questions, such as what's the number of crushers and pulverisers? For instance, if you know that and your client blank is contaminated, you can work out which samples were immediately before and after the blank. You could also ask about fire assay pot reuse and discard procedure, training, shifts. What's the lab QC rejection protocol? Do they do any external or internal round robins? The list goes on. In conclusion, why should you maximise your lab relationship? Reasons to do this include improving your understanding, assisting QC issue resolution, and contributing to effective reporting. How to maximise your relationship can be assisted by 4 non-linear practical pointers of communication, planning, lab flowcharts and lab visits. And finally, some advantages for maximising your lab relationship. You will get immediate access for the issues because you know who to talk to. Strong professional rapport makes problems easier to solve. Additionally, there might just be the possibility of a one-off assistance with desperately needed results. Don't quote me on that. With planning, your assays will be appropriate and fit for purpose. If the prep's complex, flowcharts can be used to assist sample prep personnel. A flowchart can capture when the same lab has different prep procedures at different locations, and detailing lab QC and subsampling is useful as different labs do use different nomenclature. During lab visits, you will always learn something new, and this assists reporting, QC, tracking, and decision-making. Lastly, lab visits strengthen relationships. Happy to chat later, and you can find me on LinkedIn.
Thank you. Thank you, Anitra. I'll grab that if you want. That's an excellent presentation. I really appreciate that. And obviously, all throughout the day, you've got the chance to sidle up against the presenters that we've been presenting today, including our friend from the lab, and ask your own questions. So just a reminder to those of you on live streaming, if you do have any questions, please start putting them through because we will have a good amount of time for questions. Our next presenter is Mark Perlow. He's a professional geochemist who has worked for several Australian R&D providers, mining companies, and as an independent consultant in mineral exploration problems and issues. He currently works for a laboratory who I'm sure he will mention during the course of his talk. His talk is QA/QC, the lab perspective. Thank you.
Yeah, look, thanks for that, Mark, and thanks for the introduction, Anitra. That was a really good segue into my talk today. I have worked for other organisations, but today I'm wearing the badge or the hat of a commercial geochemistry laboratory in ALS. So I'm going to try and give some tips, some advice, a bit of a spin on what our stance is on QA/QC. But before I start, I'd like to acknowledge a couple of co-workers who have contributed to this. Our quality team in Peter Sullivan, Benoit Gaffney, my colleague Miguel Martinez, and also some previous ALS employees in Sarah Rice and Amanda Stoltz. I've lifted this from Wikipedia. It's a clay tablet. You can see it in the British Museum in London, and it's supposed to represent the world's oldest written complaint. It's a complaint about the delivery of the wrong grade of copper, and it's written by the purchaser, Nani, to a merchant, A. Nazir, and he's complaining about the grade of copper that was delivered and the rude treatment of the slave, I guess, who handled that particular transaction. And it indicates that complaints about quality have been linked to the resources industry for a very, very long time. So if we're buying copper from A. Nazir or any copper merchant in Mesopotamia, there's expectations and there's reality. And one of the key roles of a lab is to help balance clients' expectations, but we also do need to deliver our methods, our products to clients that are fit for purpose and achieve an acceptable reality for everyone. As an outline of what I'm going to go through today, I'm going to try and avoid the use of too many equations and graphs and tables and things like that. And I'm going to basically use some low quality memes as a bit of a crutch as well. I'm going to touch on what geoscientists need and want to get from geochemical analyses. I'm going to touch on what quality might actually mean at a laboratory. I'll talk about some example quality queries from clients and how ALS manages quality feedback. We'll have a look at some sources of error. May not all be from the lab. And I'll endeavour to provide some tips, advice, and explanations. I mentioned graphs before. Now, graphs are a fantastic way of summarising information. However, you certainly can't graph your way to quality or graph your quality issues away. Anitra mentioned Linda Bloom in her previous presentation. She recently gave a talk on GeoHug, and you can find that talk on YouTube. It was a really fantastic presentation, a lot of really great content. It was given a fairly, well, what I think is a controversial title. She called it Dirty Little Secrets of Assay Quality Control. I think it was a provocative type title because pretty much all of the quality disasters that she showed, including a lot of edgy photos, were actually from mine site labs, often run by the miner themselves or from some government labs, rather than from established commercial professional geochemical laboratory groups. As explorers, resource professionals, you need to have a bit of a think about what you want and what you need. Typically, you're going to want to quantify geochemical variation, and you're going to want to do this at a variety of scales. It could be in a region or a catchment using soils, stream sediments. It could be down a drill hole. It could be in a mining bench. You want to look at the concentration of elements. You may want to estimate the mass of a particular element, so you can combine it with things like bulk density to get the mass present. And then there are other issues that you may want to consider into the future, how a material might process and some environmental implications. You need to understand there are multiple ways of getting geochemical information. So you need to have a good idea of what tool you're going to choose and how that particular tool works. So in terms of defining or measuring the quality of the lab, what does that even mean? How do we compare one lab to another on the basis of quality? We could look at things like accuracy, and I don't know, a potential way of doing that would be how close to certified values a lab might get when they're analysing CRMs or blanks. You could talk about maybe precision. Maybe does the lab provide consistent results each and every time they analyse a particular sample? But is that all there is to quality? What about experience? And by experience, I mean, are they proficient in actual geochemical analysis? Have they got local experience? Do they know a little bit about the local geology and the kind of commodities which are searched for? Then you've got things like customer service. Can the lab provide proficient technical support? Can they give you most of the analyses that you're interested in, or are they like a one-trick type pony? Have they got a suitable spatial network of labs in the places you need them to be? Have they got direct links to other business units like metallurgy, mineralogy, enviro, dedicated teams to focus on quality? How they actually respond to issues when they come up, and issues always do come up. Can you actually visit the lab? Are they open? Geochem labs might talk about detection limits, and there is a bit of a race to the bottom there, but it's very, very rare that a lab would state and then clearly demonstrate that they can provide more accurate data than their competitors. In reality, it's the first two that probably matter the most, accuracy and precision. I mean, you can be a really great group of people, but unless you're providing data of the quality required by the client, then the lab isn't going to get traction and retain clients. Geochemical analysis queries directed at the lab. So ALS, we log pretty much all client queries as incidents, and these can cover things like destroyed samples where the sample might have been spilled or maybe lost in transit between labs to the lab on the lab floor. It can be things like sample mix-ups in labelling or sequencing, sample prep issues in drying, crushing, pulverising, splitting, homogenising, contamination, analytical contamination. There are issues around work order write-up occasionally, where a client will say that the lab didn't do what they thought that they should do. And a lot of that comes down to communication and having appropriate paperwork filled out and describing, there can be no confusion here. This is what I'm asking for. That last point there where the client inserted CRM, blank or duplicate, returns concentrations or a concentration beyond expectation. And I've got an asterisk next to that where there is a need to define and manage these expectations. And a little bit later, I'll talk about method precision versus standard deviations and things associated with CRMs. It turns out that when we investigate incidents, the largest group of them turned out to be within ALS limits. That's certainly not to say that things don't happen. There's often instances of analytical discrepancies and contamination, but it is about understanding the capabilities of your method and not pushing it too far. So in terms of some quality assurance examples from the laboratory, remember that quality assurance is process-oriented, it prevents defects, and it involves planning and systematic activities, whereas quality control is more product-oriented. It detects defects and involves problem detection and elimination. So CRMs, blanks and duplicates are all examples of QC tools, whereas defining what to use, how to use it, how often to insert is an example of quality assurance. We use standard operating procedures at all of our ALS labs. There's no freestyling in the lab. We have global consistency, what you get from a lab here in Stafford, or in Stafford here in Brisbane. Same kind of method you can get in Lima, Johannesburg, Loughrea, wherever, global consistency. Now, our methods, we validate internally, and we also have external validation. We have controlled documents. We have quality accreditation systems. We're a NATA accredited laboratory. We do systematic QC checks and insert QC materials, as John referred to before. We collect received weights on samples. So that is one way that we know what could be a CRM coming in, because there's a bit of a size discrepancy there, a mass discrepancy there. We use barren flushes of prep equipment between batches, disposable labware for some methods, QC checks on crush and pulp sizes. I've got an example of that coming up. Spikes to help monitor positions within fire assays. We have lab vessel flagging. So if we're using like a fire assay pot, for example, and it goes high, that pot either gets thrown out or it gets flagged, so it's not then used on a low level method subsequently. Final volume checks, internal and external round robins, we participate in these kind of things. Just quickly, error of sampling. It's a combination, or your error of sampling program is a combination of that fundamental sampling error, that geochemical variance which relates to material heterogeneity. And some workers have suggested that represents up to 80% of the total variance. Error from sampling methodology, or that sampling variance, up to 15%, and that's incorrect extraction of the samples from the lot, suboptimal preparation procedures, contamination, bit of human error. And then that error from analyses, the analytical variance is a fairly low contributor to the total error of what we're trying to quantify. And that's a reason why things like core duplicates often have difficult to define failure criteria, and typically the failures are not actually actionable by the laboratory, particularly if they're related to the material itself, in other words, the geology. Here's a quick example of sampling variance. What happened here? We have sufficient samples, Northern Canada. No sample prep was performed in the laboratory at all. It was a partial leach, but some suspicious results. So there was a systematic gold response in certain sampling lines. What happened? Well, when the sample location is plotted against the analytical sequence, we can see a gold response in every second sampling line, and we can identify and consider specific laboratory runs. And it turns out that the soil sampler involved in the field there on these suspicious sampling lines is wearing a gold wetting band, and we can see that in these results here. Tips, advice, and explanations. You don't get awesomeness when you fall asleep on the job in the lab. I just thought I'd put that out there, but a lot of people like Oreos, so it's possible. Sample numbers, labels, and packaging. It's fairly simple stuff. Ensure that you're using things that are unique, they're clearly labelled, and they're not going to be lost or dispersed. Pack your samples in sequence. Take care of your CRMs, particularly if you're packing them in amongst core and rock. If you've got these little foil packets and you're throwing them in with a whole heap of diamond drill core, it's pretty easy for those things to get punctured and ruptured. They can absorb moisture, they can oxidize, bad things can happen. You have the opportunity to use barcodes to help automate the tracking. Send your sample list to the lab along with your digital submission. It helps to cross-check samples and the analysis order. Package to avoid cross-contamination, loss and mix-ups. There's some calico bags there. They all look pretty good, but there are some absolute disasters that come through the prep lab where one sample looks like it's leached into another, and they've just been packaged very, very wet and poorly packaged. I have people turn up in the car park all the time with shopping bags of samples. It's yeah. Quick example of the crush and pole QC reports that you can get from the lab. We do them at a rate of 2% or greater. They're performed at the start of every work order. You can't really see it here, but in this particular example, there were 3 pole QCs done at the start of the run, indicating that 3 LM5 pulverising mills were used there. Sample prep contamination, you need to expect some. Up to around about 1%, sorry. We do barren flushes of the equipment at the start of each batch. You can always select more. Selecting and inserting your own QC materials. I'm going to have to sort of power through this, but remember, it's common for a single prep worker to run up to 4 pulverising mills simultaneously, so there's no guarantee that sequential samples will be processed on the same equipment. If all of your blanks come back without any carryover after ore zones, just make sure that the blanks are not being taken out of sequence and they're being prepped as a batch independently, and that's not really what you want. Precision as a function of detection limit. This is fairly important stuff here, but the thing to note here is that precision improves. You get a lower number expressed as a percent as you move to concentrations higher than the detection limit. And it shows 2 different methods there, MS61L and an ICP61. We use method precisions at ALS, and both of these methods have a method precision of 10%, but they have very, very different detection limits. And so at an average cross-cell abundance of molybdenum of around about 1.5 parts per million, you can see the precision in that MS61 method is around about 11%, whereas from ICP61, it's up at 76%. And that can have a big influence on what you can then do with the data. This particular example here shows selenium duplicate pairs with a previous version of a method and effectively the same method with improved detection limits. The improved precision at the lower detection limits is illustrated by the change in duplicate performance, and the graph shows that samples that were analysed twice with a detection limit of 0.1 and then with a larger group of samples in blue that were analysed with a detection limit of 0.003, the improved precision can be seen by the points more closely conforming to that line. What do explorers use in terms of control limits? There is a tendency to rely on what are called the traditional Shewett rules, where you get a warning if your result falls between 2 and 3 standard deviations and a failure if that result falls outside of that. It's not uncommon for 2 to 3 sigma limits to be tighter than the method tolerance used at a lab like ALS and consequently trigger perceptions of failure. It's not a cut and dry issue. Labs and clients need to work together on that. ALS control limits. Here we got 2 sigma limits for 4 different CRMs there, despite them all having a very, very similar gold concentration of around about 1.8 ppm. You can see that those error bars range in size quite considerably. CRMs have differing ranges, even at relatively similar concentrations. And so ALS have adopted method precision because it establishes target performance expectations for the analytical method that are not a factor of the material itself. It ensures consistent targets within the method, and it takes into account method differences. Expectations are different for different types of methods. So our geochem methods typically have a method precision of 10%, fire assay 6%, all grade methods between 3.5% and 5%, umpire methods 1 to 2%, and some commodity methods between 1 and 2%. This is what the lab does when we consider, well, we certainly consider method precision expectations, and this is how we assess the CRMs and duplicates that we will put into our laboratory runs. When you might consider requesting a reassay, you can do it at any time, but try and understand the method precision expectations of your chosen method first before firing off a terse email to the lab. Work out if your materials may be out of control or biased. We will investigate every client inquiry regarding quality. We will reassay the standard and surrounding samples. You don't need to identify the sample itself. You just provide a range. If a reassay shows that the issue with the digestion analysis is legit, then we'll rerun the batch and extend and perform an investigation at no charge. If the reassay agrees with precision limits, then the reassay may be charged. It's something that you really need to discuss and work with the independent quality team at ALS. If you just take a hard line and say, no, it's no good. I've got 2 minutes. Thanks, Mark. I'm bringing it home. Lab audits, inspections and visits. We have an open lab initiative where your results are held by ALS in perpetuity, and you can get access to them. You can track things like chain of custody and QC data, and we provide an audit trail of who's seen what. If you do think an audit is in order rather than a lab visit, on audits, ask yourself if you're qualified and competent to effectively audit a laboratory. Regular inspections and visits are welcomed and actually encouraged. And it's, as Anitra said, it's getting that relationship with the people either at your lab or the quality teams or your quality service type teams. Other tips and advice. Let the lab know what you're doing, what you're trying to achieve. If there's anything weird in there, hazards, what you're really interested in. Develop that relationship with your lab and work together. You might not like me, that's okay, but then there's a local lab manager, there is a client services team, there's a quality services team that can all provide really good advice at little or no cost. Do that prep and lab tour, do it semi-regularly. Doesn't matter if you saw it at university, come regularly. Routinely review and make appropriate changes. There's no excuse for doing the same thing all of the time. There's heaps beyond what we show in our schedule of services and fees. I don't think I have a particular quality hobby horse. I think of myself as a bit more of a rough rodeo rider, but not a cowboy. Quality does come at a price. So there's that frequent need to balance quality with price. We do it in the lab. You will do it as explorers and mineral professionals. There's only so much you can pay for. If something does look a bit different, ask, how can someone do it at that kind of price? We do annual client surveys. We get that feedback that ALS can be a little bit more expensive than our competitors, but we also do get that feedback that clients are very happy with our quality. And on time?
Perfect.
Absolutely.
Thank you. Thank you, Mark. And it's pretty obvious that the messages from Anitra and Mark are pretty well aligned. Communication. No, but it's all about communication, understanding exactly what you want and then how to measure that. Our final presentation for today, this session was prepared by Dennis Arney. Dennis has over 40 years experience in geology and applied geochemistry globally. He recently contributed to a review paper titled Practical Applications of Quality Assurance and Quality Control in Mineral Exploration, Resource Estimation and Mining Programs, a review of recommended international practices, and Anitra referred to that in her talk. Now, those discerning people in the audience might look over here and think, that's not Dennis. So Dennis wasn't able to attend today. He's prepared to talk, but Mike Whitbread has jumped in to present the talk today. I'll introduce Mike formally next session because he's actually presenting on behalf of himself next session. But Mike is currently going to present Dennis's talk, QA/QC data, how good is good enough?
Thanks. Am I coming through okay up the back? Excellent. Torps. Thanks, mate. Thumbs up. Right. So, sorry. It is on. Right. So, yeah, Dennis is taller and better looking and has a nice North American accent. I'll do my best to emulate some of those features. Now, really, thankfully, everyone who's come before has sort of set the scene a little bit and probably stolen some of the thunder to some extent. But we, as an industry, we do a lot of QA/QC, or we say that we do, and what is good enough, right? And I guess at the risk of spoiling the entire talk, the answer is, and you've heard it before, it depends, right? So it depends what you want to do. So it's an example here, which is actually not, it's only partially related to assaying in itself. It's just QC, we often focus on the train wrecks, right? Because they make great stories and presentations, but there are upsides as well. And there's an example here where they got better density information effectively and were able to upgrade their resource. This is not my example, so I'll do my best to talk to Dennis's slides, but you'll have to ask him about the details of some of these. But in my own history as well, you know, there was an example where we were able to provide, back when I was a consultant, a 10% upgrade to their resource, just on the fact that they had used an XRF method, but their ore was a bit harder than they'd expected. And actually, because the grind size was not the same size as what the extra instrument had been calibrated on, they actually were undercalling their result on the initial results. So you never know what might pop up, right? This is, and so it's a part of QA/QC is around identifying all the things that might be affecting the value of the project that you're involved with, whether it's exploration or at the mine, or even when you're in the mill. So if you look at the statement where the underline in, we've got it here. You know, how much do we actually talk about in our reports about what is the acceptable levels of accuracy and precision that we're looking for? And so, you know, Dennis has got some examples in here. The first part of the talk is going to be around what's good enough from a duplicate point of view, precision point of view. And then the second part will be what is good enough from a CRM point of view. Now, John's already covered some of that, and Mark's alluded to some other bits as well, but we'll give you some other examples in here. So there's a bit of a table here of a typical, inverted commas, QA/QC program. And there's even percentages there, or insertion frequency rates. And I guess this is where I'll probably insert my view over the top of Dennis, because he's not here talking and I am. I tend to stack in an exploration program. I stack more duplicates in than standards, because when you're in exploration, you're looking at anomalism. That's a relative thing. So you want to make sure that you've got signal to noise effectively. And that's where precision becomes important. Now, when you get down to the end where actually people say, well, how much copper is actually in that rock? And what am I going to get at when I chuck it through the process and get it out the other end and sell it to someone? Accuracy becomes much more important. So you may want to change your insertion frequencies of your standards and stack them a bit higher in the back end of the process, or when you get towards the mine. So these are, I guess, a guide, and how much QA is enough. It depends on what budget you've got and what you're willing to withstand. But typically a 10% insertion rate of QA is a reasonable thing. But if you go to, I've been in projects where people have had 25% QA, and that's really expensive. So for every $100 you're spending, there's a lot of that not going on the actual assay of your samples. So you need to think about what's fit for purpose, what's going to give you comfort, and the person who's ultimately going to sign off on your resource, if that's where you are, what's going to give them comfort to put their signature on something. So clearly duplicates are around precision, and it's precision of different things depending on where you're measuring those duplicates. And we'll talk a little bit more about that later. And then, you know, what we're calling standards, the industry uses the term standard, and there was a good point, which is that we probably shouldn't call them standards, but people are going to do it. And I guess one of the things that I will say is that no matter what you do or who you work for, when you go from one place to another, the terms change. And actually in some places I've asked them, say, can you just print something out and stick it on the wall about what you're calling a lab replicate, a machine replicate, a lab duplicate, an umpire, a check, an internal check, a second split, you know, and you say that to different people and you get a different answer, right? So it is really good to make sure you're all talking about the same thing. So what makes, oh, there's a bunch of things in here. What makes for a good program? And really we're going to talk, there's lots of bits here. Other people have covered many aspects of this already. We're just going to talk about numbers that you can assign that give you comfort that either your accuracy or your precision is good enough. And I've covered the fact that, you know, earlier in the process, if you look at exploration results, what you may do there should be a bit different when you're down the other end of the process and you need to actually convince someone you actually know what's in those rocks and you want to get money from the market. So let's talk about relative precision. And it's already a term where people go, well, that means something different depending on who you talk to, right? So, and we'll cover that in a minute. But yeah, Dennis and I used to work in a company called IO Global back in the day, which is why he's trusted me not to stuff his presentation up too much. But we have I guess, a bit of a shared history with Dave Laurie and Cliff Stanley around an approach to measuring variability that suits us in the roles that we play as geochemists. And that's really the CV, which is, your standard deviation over your mean for whatever it is that you're measuring. And it's called the coefficient of variation. And it's related to many of the other, I guess, measures of variability that you'll see depending on who you're working with and what their background is. And the reason we like a CV is it's quite easily relatable to other measures of precision. And there is no test after this about how to calculate the averages and all that kind of stuff. It's really to say, if you, like in Rio, where I work at the moment, we actually use MAPD and MPD, which is a bit like the hard, really. And everyone has a different term. It doesn't really matter so much. They're all relatable, but it's how you're using them to say, well, what's good enough precision? So coefficient of variation is actually much easier to calculate. And it varies with concentration. So any method that you look at, if you're close to the detection limit, your error, your measurement error is actually quite high, right? So some labs have a 2 standard deviation of 100% precision as where they set the detection limit. Some are more conservative, but you shouldn't expect the same CV if that's what you're plotting. You can have hard in here and the numbers will be slightly different, but it doesn't matter. If you're in a project where you've got a lot of data coming in, your data is telling you what's good enough in a way from a process control point of view. Now, there are other things you can compare to work out whether overall you're still within acceptable limits, but you've got to get away from your detection limit. So if you choose a shoddy, cheaper analytical method that has a high detection limit, that means you have to be at much higher grades before you can trust that data at a certain level of precision. And this is important if you're looking at cutoff grades. So it's not just the juicy stuff, which has got a lot of, we've got a gold example here. Everyone loves a bit of gold, except for Rio Tinto. We don't mind gold. So, but you need to make sure that your precision is good enough where you're making decisions. And it's actually important for CRMs as well. Are you inserting CRMs at your decision point grades? And are they good enough for the method that you're choosing? So the other thing to remember is if you're calculating these errors and if you're taking a field duplicate versus a crush duplicate versus a pulp duplicate versus a repeated measurement on the machine, in the field duplicate, all those other errors are included. And if you're using CV, because it is a standard deviation over a mean type calculation, you can't just add them together. You have to add them as variances, which is a square of that. So now the useful part of this is that if you collect a field duplicate, whether it's quarter cores, half cores, a sample in the same hole or a sample that's 1 meter apart if you're looking at soils, that's going to have a lot of variability. And often the resource guys that I talk to, they go, don't bother doing field duplicates. It washes out in the stats. It's okay. And I go, well, how the hell do you know if you've actually made a mistake in the sampling itself or in the core cutting? There's some great examples of previous company I worked for, where the local core cutting crew wanted the mine to do really well, so they made sure they rotated the core to get the grade in it every time, right? And the only way to pick that up, aside from someone watching them do it, which is really boring, is to look at your field duplicates and you go, hang on a minute, there's some pretty big variation in there, and that's clearly not good enough. So if you capture field, crush, and pulp, you can start looking at the proportional contribution to your total error through the variances. So the reason that's important, if you monitor that over time and you see that the value of the pulp duplicate error, literally getting a gram of sample out of the little bag, if that's creeping up, there's something going wrong with your pulp packets or the way it's being done. Typically, they're quite a small proportion and most of it's your sampling error. But if you see those proportions changing with time, it tells you that either the nature of the material is changing that you're dealing with. Sometimes that's really insightful in terms of maybe the hardness of your ore is changing or the nature of the mineralization, or it can be something is breaking down somewhere in the process, in your sampling process. Most things go wrong during the sampling, not at the lab. Mark didn't pay me to say that. But so what's good enough from a CV? And I'm not saying this is actually good enough, but these are numbers that are out there. Absolov put some numbers out. Absolov was working for Rio at the time. This is well before my time in Rio. And we don't actually know what data he used to pull that in, or at least I don't, and Dennis doesn't. But these are not bad as giving you an idea. If your variance for different types of samples or different material types in different ores, you know, because orogenic gold could be quite a bit worse than certain other styles. What's good enough? If you're outside of these, you need to ask yourself why. And you know, a lot of people go bonkers for Bongason and Petard, right? They try and calculate things in advance. I almost go the other way. I go, look, bring those guys in when you measure the error and it looks bad, because they can work it out, right? They'll help you work it out, but measure your variability. And if it's not looking good against some of these kind of numbers, then you probably need to have a bit of a think about it. Now, what I would encourage people to do, have I got 5? Are you looking at a bit more than 5? Oh, wow, going ahead. Now, what you can do, and I strongly encourage this, and I guess customers of mine, both internal and external, that I like to talk to, tend to listen to me about this one, and they implement a measurement of their own data over time. So if you know, if I give an example from Winu, because we'll talk about that later anyway, you know, they have a few 100,000 assays there now, and there's a lot of duplicate data in there, and we're able to establish what is the typical CV at any batch for any of the duplicate types that we're collecting. And if that changes, then you can actually do it as a line plot. Then you don't have to do anything fancy. Once you've looked at your CV value, you can look at the 95th percentile of that, the 99th, whatever threshold you want to set, and you're measuring against yourself. It's like a process control at that point. And if it changes and it's getting worse, you need to go and inspect whereabouts in the process that's happening. 5 now. All right. So, and that can be the nature of your ore, right? It may be nothing, you may be doing nothing wrong. It could just be something changing in your mineralization, but that's pretty important to pick up. So data accuracy and bias. So it's already been covered about what a CRM is, right? It's really important to make your own. If you're in an advanced project, and we love these guys up the back, I'll say that, Oris, we use their standards a lot because they go through the hard work of characterising them with a multitude of labs, and their processing of that data is pretty reliable. We end up with something that we trust, right? So that's what you're looking for in a standard manufacturer. They're not the only one, so just so I'm not looking like I'm biased, but that's why we like their standards. And you've got to look at the way your standard's being manufactured. Now, you should be doing your own, because even though they provide material that's pretty close to your mineralisation, ultimately you want it to as closely match the kind of material, the particle size, the variability that's in those that you're going to experience in your deposit if you're at that point. Look at the labs that are in the round robin data. And you can see a couple there that are kind of different. There's the teal and the green is quite a wide value. There's a lot of range in that data. That's a bit of a worry. And the blue was averaging outside of 3 standard deviations from the other labs. Now, that doesn't mean that they're wrong. It's not quite possible. It's unlikely that everyone else has stuffed it up. But you need to understand that your CRM is really only telling you what I guess a panel of labs would give you as a number. And you've got to hope that's close to reality. And you can do checks later on. I use the word check there in a loose sense to work out whether it is truly accurate. We've had instances where we've, and we use ALS quite a lot. We've had instances where a particular analyte from them will be biased compared to the average. And as long as it's within a certain level of bias, we're quite happy with that. But if you start to see things that are flying outside, you've got to work with the lab and say, well, why are you different to everyone else? And sometimes it's a slight change in the way that they might even do their acid digestions. So do they bring it to dryness first, or are they a bit looser with that, or is old mate a bit drunk when he's in the lab on a Saturday? So you've got to work with the lab around why the differences are there, and whether you can actually adjust the limits from a process control point of view when you're in an advanced project. And the whole 2 standard deviation, 3 standard deviation fail thing for standards, CRMs, we really would encourage people just to not hit the panic button just because one sample's gone outside of 3 standard deviations. And it used to be consecutive samples outside of 2 standard deviations. Look, you've just got to use all your historic data, and I'll show some charts this afternoon in my example of highlighting that. Use your own data to tell you whether this is actually happening more than, say, 1 in 1,000 for a 3 standard deviation fault. If it is, ring up the lab. Don't abuse Mark too much, and talk to him and say, look, we've got this happening. Why is that? And that little standard deviation curve is in there just to remind you that 3 in 100. 3 to 1,000 is what you might expect for a 3 standard deviation, and 1 in 20 for the 2 standard deviation. Sorry, I gave it 1 in 1,000 before. So look at your data over time. Don't just look at it at a batch level. The batch level gives you an idea, but you've got to work with the lab as well. And what is the thing that, well, there's a bias thing that we're talking about here, is because some of the labs will always, well, there's very few of the labs that will exactly straddle the accepted value for a standard. So there's always going to be some bias compared to an accepted value that they're going to supply you. And does it matter? And the answer again is it depends. And what's good enough for your resource person to say, well, actually, we don't, got to remember what the method precision is as well. So if you're going to worry about a 1% bias in a method that's got a 10% precision, it's probably not that big a deal, unless you can demonstrate, maybe with some umpiring using even a different method, that you're actually not capturing all the metal correctly, or you're getting too much. 1 minute. All right, so there's some numbers here to work with. Relative bias 2% for a standard. Use your CV. Make sure the CV of your standard isn't too tight for the precision of the method that you're using. So, if your CV is 5%, that's probably good for a 10% method precision, give or take. If it's tighter than that, you may be being too hard on the lab for what they're offering you as a service. So let's finish up. Quality control precision. Use CVs or something like it. Use your own data over time to look for changes. Use, if you can get data from elsewhere in the industry for similar deposit styles, similar sampling, to tell you that what you're getting is acceptable depending on the sampling stage you're within. Monitor the internal contributions of error at the different sampling stages, and make sure they're not shifting through time and that something is creeping into your process. And accuracy, we just went through all that. You can get both accuracy and bias from your standards. We didn't even talk about umpiring or check samples with an external laboratory or external methods. That's really important as well, because remember, a standard only tells you about what's in the standard. It's not a test of all the samples around it, because they will be slightly different. The only test of the samples are those samples. So send them off to another lab, and we get into arguments with people around that all the time because they complain about the cost. But that's where you really pick up some geomet issues sometimes by umpiring correctly on the actual pulps of your standards. And that'll do.
Excellent. Thank you, Mike. John and Anitra and Mark, if you can come back up to the stage, that would be good. I'm going to share that for you guys you just have to turn it on. Have you got any questions from the floor, Peter?
They were covered.
Okay. All right. So we've got plenty of time for questions. We already have one over here. I'm sure that there's going to be lots of questions. So we'll come over to here. Here you go, Nick.
Thanks, Mark. Thanks, everyone. Again, that was a great session of talks. There's 1,000 different things we could talk about there. I suppose from a practical point of view, though, I would like to direct question is pretty much to all of you around when it comes to inserting CRMs into a batch. Let's say you have one batch from one drill core, you manage to get 100 samples in, and you have your protocol is to insert 4 CRMs in an area where you've got a bit of an idea of where the mineralization should be. Should you make sure, in terms of the choice that you have to make, that you've got a range of different CRMs with different values that should cover the full range of the rock types and mineralization that you see? Or should you make sure that where you are inputting and inserting CRMs, they match the rough % of mineralization that you might see? What would be your preferred choice?
I'll go first. All right. So my view is ideally, yes, that you should actually choose things that are appropriate for the type of material that you're doing. In practice, it never works, right? Because unless you're you're doing it all yourself, you trust yourself to do it all, and you've got not too great a volume of samples. What we typically find, particularly as you go in an advanced project where things are just going helter-skelter, right? If you don't make things regular, people stuff up, right? And they make mistakes and you end up causing more trouble than you solve. So we tend to, and this is in my previous life as well, my current one, we tend to mandate where things go in. We do offer the geologists the opportunity to insert extra if they want to around something that they're curious about. It's almost never taken up. So,
So if it was, say, you've got CRMs that are 1, 2, 5, and 10% copper, would you make sure that you have that full range in one batch that may go to the lab?
yeah,
If it's one single, or would you choose?
so we rotate through the standards. Yeah. So that's my answer, and I'll stop. So give someone else a chance.
I think it's fair enough to rotate the standards around. And obviously, if you have internal standards, you may actually choose to run that one in every batch. So you have this underlying current of information, and it's a better match to your data.
I'll have a crack as well. Have a look at Linda Bloom's recent GeoHug talk. She gives a couple of what I think are good guidelines. A CRM, which is around about the concentration that might trigger an overrange method, is a good one to have in. A CRM which might align with your lower mine cutoff is a good one to have in. But outside of the mine, I mean, if you're doing generative or greenfields exploration, try and get things which are appropriate. Don't say, well, we went cheap and we didn't actually buy our own CRMs, but we'll go and talk to the mine guys and see what they've got in the cupboard, and we'll just throw those ones in, because it does happen all the time, and you see these very, very low levels coming through, and then all of a sudden absolute screamers in cadmium or something like that, just because it's a really obscure CRM that's been thrown in. And another point which I didn't really hit on in my talk too much is selecting your CRMs. Try and match the matrix as best you can. If you've got Aureus provide a whole heap of detail in the materials which they've got, whether it's weathered, how mineralized it is, the kind of matrix. Try and get something as close as possible as you can to what you're drilling through.
Hi, Rod Carlson here. Thanks, everybody. Great talks. True to heart, my heart. I've been there, done that. So thanks for that very, very much. I guess to Anitra's point around get to know your lab manager, totally agree. Those 6 times in a lab sort of pales into insignificance when I was in and out of a lab every day for the best part of 5 years. So, but look, it's so important, that relationship, and I can't stress enough that you brought to home so many of those issues that are absolutely critical. Just one question, perhaps to Mike, might be the best person to answer it. In relation to conducting the certification of standards if you're doing your own, when I last did them, there was quite a lot of variance between laboratories. We did it not over 15 laboratories, but over the 5 local labs at the time. And there were distinct, repeatable differences between the labs at the time. Have you found over time that the commercial laboratories are generally becoming more aligned?
Oh.
Was that too broad a statement?
That's a very good question. Yeah, look, how do I answer that without defaming someone? But what you tend to find is that some labs, and this particular lab hates me using this example, I won't use their name, but they're like a high-class McDonald's, right? So wherever you go, you get the same thing, and it's pretty consistent. So some labs are like that, where they're very consistent, and it doesn't matter which of their global labs you use, you get a similar result. But there are other labs where when I know the lab manager is running the show over here, they tend to perform well, and wherever he goes, it performs well. And then as soon as he's out of there, or he or she, it all just falls over, right? So this is where you look for companies that have good internal systems as a lab. And you're talking about the analysis of the standards in particular? Yeah. And that's probably enough of an answer, I think.
And just to follow up to ask Mark specifically, is there any increased collaboration, communication, discussion amongst the labs commercially to review and improve systems throughout the industry?
Certainly not that I'm aware of. It isn't as though we sort of catch up for lunch once a month and discuss, next month's CRM results and what's going to happen there. At least my experience, and I have I've only been with ALS for 4.5 years. We've got employees who've been there for over 40. It doesn't happen. We don't talk to the other labs that often. We obviously see them at conferences and things like that, but it never really comes down to talking shop at that level of detail.
Question?
Renee speaking here. I've got 100 million questions. And can I get away with 2? Because John, you started talking and I thought, okay, I have 100 questions, but then, other people started talking. So I have no questions other than to say your thoroughness there is an inspiration. I mean, that's exactly what makes this stuff work. Your presentation was fantastic. I think I just wanted to share that. I need to, same thing, questions, but maybe over lunch. I've saved my 2 questions and they sort of started getting more interesting as the talks went on. So Mark, I think you talk about what is quality, and I find it a fascinating word, and we can put all the dartboards on the screen all day long, right? And we can say, okay, accuracy and precision, great, now what? Right. And later I've got a talk and I started talking about DQOs and you started talking about precision values, and we can do more there. But perhaps to turn into the first question for yourself, when the lab has a contract with a client and they have a quality clause, I'm fascinated by those clauses because there's nothing in there that you can hang your hat on. And I understand why that is, right? Because you've got your tolerances and your method precision. You get all of that, but that communication with the client at that level already breaks down almost everywhere. And it's hard to get to a point to create a system that is truly quantitatively thresholded to what is good enough or not. And I love your talk as well about what is good enough, because I actually believe we can get there. And I've got a question for you in a minute, but the question for yourself. So from a lab contract perspective and the word quality, how do you think we can do better in capturing what quality means so that indeed you can get rid of all those freaking resubmissions that are a complete waste of everybody's time, right? So could you do something with that question?
Can't really answer that, I'm afraid, Renee. We don't like resubmissions. We don't make a lot of money. We don't make money from those kind of things. They delay things. They clog up the lab. What can we do about it?
Well, so maybe as an add-on, so there is a book by Miller and Miller that you're perhaps familiar with, 2002, and it's Chemometrics and Statistics in Geochemical Analysis. And I bought it because I'm a dumb geologist and I didn't understand it. But they've got a quote in there that says, none of the laboratory managers in the industry actually understand the basics about statistics. And that really grabbed me because, as most geologists here, we suck at statistics and I had to work hard for it. But it does create a problem because all of this is about statistics. The moment you go 3 in 1,000 and you say that's a threshold, you kind of have to understand what that means. And if you just look at C-class and what bubbles out of that on your old sort of green and red hued plot that SGS, I'm sorry, did I say that, is still using, then you can't do much. So the question is, is there really no improvement we can make to the principle of quality? Because that's why we're in this room. There's a Q in the title of today's presentation, and it's an interesting word. And from a laboratory perspective, I think we can do more. So yeah, again, the question.
Yeah, it's getting that that definitive actionable kind of point that that moves things forward. Sorry, I'm going to have to.
Mark, I might. I'll jump in as someone who frequently has resubmissions with a certain lab. And one of the things that works is setting an expectation around method tolerance and we can communicate that with our geologists, right? And that we say to people, if you send something back to the lab and this basic criteria is not met in terms of, okay, look, it's within the method tolerance, so don't stress about it. If we insist on that and it turns out it is our fault, which typically is, and not the lab's, then we have to pay for those samples. And that really focuses the mind, right? When you have to pay for something, typically what happens is when we put things in as genuine questions, we don't have to pay for them, right? Because usually we've done that pre-filtering. So I think one of the best things to do to lower the amount of resubmission is to make sure that there's a very clear expectation around what the lab will not accept as their fault, right? And you go from that side and you put a cost to that, and costs tend to make people pay more attention. So that's from my perspective.
Hi, Jeff Phillips. This is a query that's probably best directed to Mark. I don't want you to feel like we're picking on you, but we are.
I never
So
came here thinking that anyone would ever pick on the lab, but
It's around the formality of a complaint. And so the scenario I've been in, we've had Anita's flowchart and all the junior geologists are using that to the extent of even when there's a QA/QC or QC failure, they follow another flowchart right down to the bottom where we've convinced ourselves that there's a problem with the batch. Now, my request to those junior geologists has been, do not re-assay, resubmit until you get the investigation from the lab. So my question to you is, how do we get away from these horrible email responses which say, we looked into it and nothing's wrong? And it goes round and round circles. I've insisted on ISO reports. I've insisted on other 3- and 4-letter anagram reports. Is there a type of reporting which gets us away from every complaint is an incident, which is, I think, what you are doing in ALS, to those significant investigations packaged up into a report we can stick in the back end of our QC report with our NI 43-101?
It's great feedback, Jeff, and yeah, we can certainly take that on board. But yeah, I get what you're saying there, where you can't. It's harder to put like an email from the local quality team representative into the back of your report there, and you need something a little bit more formalised. In some of the investigations, when they go through to their they follow their course, we can certainly amend analysis certificates and things like that. Other clients don't like that happening so much because they run into problems with their database whereby they have a submission with a particular sample ID and won't accept 2 numbers and things like that. But yeah, no, it is good feedback. I'll sort of certainly pass that on to the quality team at ALS. Something more formalised for outcomes rather than a casual. We looked at it and it's nothing to see here.
We could spend a lot more time on this subject. Luckily, you can continue to have a conversation with these 4 people during lunch as well as over drinks. I'd like everyone to put their hands together to thank these 4. And just to confirm that we will be back here sharp at 1:50. I'll herd you back in. We have a presentation from Craig from Plexa, which is going to start at 1:05 for about 10 minutes. And then we'll be into session 3 at 1:50 on the stop. So again, I hope you've had a great session. It's been fantastic talks all around sampling and analysis, and we could have a whole day on sampling and analysis, but we're definitely not today. So thank you again for this excellent presentations today. We'll see you after lunch. Enjoy your lunch, which is straight outside. Thank you. So we've got a presentation that's being done by Craig Gadaloff from GAD Solutions. This is pretty well an opportunity just to get a bit of a demonstration on the Plexa software and the Plexa package. And I'm going to just straight hand it over to Craig now. So thank you.
Thank you very much. All right, thanks everyone. We'll just take hopefully 10 minutes just to, just give a quick overview of Plexa. Plexa is our cloud-hosted software as a service geological data management platform. At the heart of it, it's a hosted SQL database for blob storage, and we have our main web app as the interface, so there's no installation of applications, and we have a mobile app and tablet app for field data acquisition. So I'll sort of keep this as brief as I can and really focused on the QAQC side of Plexa and how it can help with your exploration programs. So when we come into Plexa, all right, let's close this guy. And this is a very impromptu live demo, so we'll see how we go. So Plexa has an inbuilt workflow for your data from planned holes to in progress, drilling complete, logging complete, and finalised. And the whole idea of that is to trigger certain validation points along the way and ensure that you've got all the data and that it's all valid. So when we come into actually running through a drill program, we have our basically what we call our hole tracker. So for whatever data sets you're collecting, and there's some that are standard to Plexa and some that are configured by you guys, you have that status of the holes, the type of hole, whether you've got the data or you don't have the data, because it's hard to validate data if you're missing it. So, and those requirements can be set like in the scenario here, if it's a diamond hole, photos are required, stuff like that. So you can quickly see what data you've got, and there's those, we've got it and it's good. We've got it and it's got warnings for some reason. It might be exceeding the depth of hole, or we're missing it. So that's just a tool to help manage your data through that program. Built in the Plexa is our map component. Now this is, again, it's not meant to replace the GIS system. It's all about helping you managing your geological data. And as geologists, we like to be able to visualize where our data is. And we're going to pick up if we've got a survey that's been coordinates around the wrong way or those sorts of visual cues that we look for. Coming down to the analysis side of things, one of the things that we really look at with Plexa is trying to automate as much of the data collection, so we as humans don't have to have a part of it. So when we log our data through the logging app, it's automatically transferred straight to Plexa. Same with our core photos, so there's no handling those manually or emailing them to ourselves. It just turns up in the system with the correct naming and validation. Similarly with the lab and our ALS friends will like this bit, we integrate with labs, with Index, with ArcGeos Online, with CorePlan through APIs. So other cloud-hosted providers, it's really, really good to be able to transfer data through programming interfaces. So the lab example, we can automate querying the lab job status, and normally it's done every 4 times a day, and that'll pull back both jobs that have been registered as well as finalised. So when the samples lob up to the lab, they're registered normally in the first day, and the results may take 2 or 3 months. So with the registered samples, day one, we can be validating them against the samples in Plexa and returning an error to say, hey, you've got samples that logged up the lab today and there's errors. So you can address those errors as quickly as possible. All things being good, those jobs come into the system and we can start looking at the QAQC. So when that data comes in, they come in as pending. And when it comes to our QAQC, we drill down to trying to see a little bit more, we can configure the different lab elements that we want. This is the base metals example. So we've got a number of elements and we've configured different cutoffs and stuff like that. So we can then either plot just that one batch. So we've got the charts per element, or we can basically have batch filters to say it might be 3 months, or in this case, it's a little test database. So we can pull back all the data for all batches. That's a fairly sort of larger request. And we can come through and quickly see, you know, what elements we've got and where they're got issues. We can go full screen. We can export that to an image to put in a report. Similarly with standards, again, we're pulling back all the standards and we can flip that. And the way we've done the charting for these standards is taking the sort of normal 2-3 standard deviation chart and flips it on its side. So when we've got a number of standards by number of elements, we can very quickly just scroll down and visualize those and yeah, hone in on any issues we may have. So all things being good, we can then approve that batch or go and query it. Our request for analysis, again, you step through a normal process. Utopia is we've collected the data in the field app. They've been synced or samples to Plexa. We can then now dispatch them to ALS, again, who have good APIs, where it goes directly into the ALS system programmatically. So we actually don't need to have any mind mucking around with sample numbers, and then we automatically pull them back. So really minimizing those chances of errors, human errors. We're very keen to work with other labs with using API technology to automate these sort of processes, because I think industry standard wise, it's a great advantage. Coming down to the graphic log. So again, about visualizing your data. So these graphic logs, we can plot really anything that we've got in the database in a line chart, a categorical chart, bar charts, etc. Again, here we're just plotting sulfides versus the lab results. You can grab another hole. It's probably the same data, but you get the idea. You can plot 2 holes next to each other. So you could use this for comparing umpire holes, you know, graphically. See how those assays have come back. Again, all the photos are captured and uploaded from project. So we've got at our fingertips the all the photos that have been captured. You basically get a thumbnail version of the photo. These have all come directly from the phone, and you can, you know, easily zoom in. Obviously, all of this stuff can be opened in separate tabs, so you can have dual screen where you've got your map or your data and your photos and a lot. So I suppose to leave us a little bit of time, that's a very high level, quick view of just the key QA/QC processes and tools. We're about trying to help with the processes. You guys can then configure the details. So if you want to use CV instead of mean percentage difference in your QA/QC, that's all configurable on a client by client basis. Yeah. Any questions?
Question. I already know if you've got something going on with the ALS, you already have an arrangement with ALS.
Yep.
So if I'm using Plexa and I'm using other labs, how do I bring you two together?
So then you have a normal traditional import of your lab job.
Yeah.
Yep. Which has all the normal issues, but
I got a question. So you actually connection you can get this is an shopper.
yep, that's right. So your downhole surveys, all that, we can automate bringing those into Plexa on a whatever routine, you know, daily, multiple times a day. So. So easy. If you want to know more, yep, please grab me and I'm happy to talk your ear off. Thanks a lot.